All right, welcome to my screencast on ocean currents and the gyres that they create. You guys have hit the highlights of lesson 1 and 2 for Unit 8, which covers winds and ocean currents. And it's important for us to realize that those winds and ocean currents, primarily the surface ocean currents is what we're talking about, set up really large circulations in the world's oceans. And those 5 main circulations are pictured here, okay? The North Pacific Gyre, the South Pacific Gyre, the North Atlantic Gyre, South Atlantic Gyre, and the Indian Ocean Gyre. Those are set up because of the winds and ocean currents and the way that they are moving across Earth. So what we're going to do is we're going to go to a global map and we're going to look at those ocean currents and the winds that create them. Okay, so just hang on just a second. We're going to change gears and go to our worksheet. All right, as you guys have learned, because of the rotation of the Earth, there are different wind patterns that are set up along the surface of the Earth, and they depend, which way they blow depends on the latitude that you are at. But generally speaking, we have easterlies, we have westerlies, and we have trade winds. Okay, it's kind of hard to see maybe on your diagram, but this marks 60 degrees. This marks 30 degrees. This marks the equator, 0 degrees. This is 30 degrees south. And this one is 60 degrees south. They are marked, but they're kind of hard to see. Okay? And we know that between the poles and 60 degrees are what's called your polar easterlies. Okay, and on the map that you have, there are some faint gray arrows which represent those winds. So we're going to pause for just a second, and I'm going to draw in or trace over those arrows that show you the polar easterlies. Okay, so I drew in the polar easterlies. Now we're going to look at between 30 and 60 degrees, both north and south. Those are your prevailing westerlies. So we're going to write that in, and we're going to draw those arrows as well. Okay, as you can see, I've now drawn in those prevailing westerlies, both in the southern hemisphere and the northern hemisphere. They generally go from west to east, generally going from west to east. Okay, and then between the equator and 30 degrees north and south, we have the trade winds. Okay, and they generally flow from east to west. So we'll draw in those arrows and label those. Okay, so we've drawn everything in, and you can see that the arrows that are closest to the equator, the black arrows, generally go from east to west. Between 30 and 60, they generally go from west to east. And generally between the poles and 60 degrees, they go from the east again. Okay, I want you to come up here, and you're going to add a black arrow. And just remind yourself that those black arrows are representing your surface winds. Okay, the next thing that I want you guys to realize is, first of all, the equator receives more direct sunlight, obviously, than the poles. So generally speaking, along the equator, we're going to have warm water. And most of the time, the little red arrows, which indicates warm water currents along the equator, they're generally going from east to west. Okay, down here between 30 and 60 degrees south, and up here, even though there's more land to interfere, up here between 30 and 60 degrees north, you generally have some cooler water, and most of those arrows, they may not point perfectly from west to east, but generally speaking, they're more west to east. Okay. And so what I want you to do, first of all, is take a red marker, and we're going to label all of these warm water currents. And then we're going to take a blue marker, and we're going to label all of the cold water currents. And if you look, you see that most of your cold water currents are closer to the poles, and you're going to see that most of your warm water currents are closer to the equator. It's not perfect because you do get some little random mixing because of all the land masses, but generally speaking, that's the case. Okay, so let's do red for warm and blue for cold. All right, so it's possible that you're probably looking at a black and white copy, so it's going to make it a little bit harder to tell the difference between your warm and cold water currents. But if you look carefully at what I did, the blue, all of the ones that I've marked in blue, those are cold water currents. And I'm going to go ahead and go over my little arrow to mark the cold water currents as well. And then I'm going to take my red marker and I'm going to mark all of these warm water currents with red. Okay, so you should have something that looks kind of like this. And again, like I said, if you're dealing with a black and white copy, just take a little bit of extra time and make sure that you're marking the correct arrows with red or blue. Now, what's interesting once you get this all marked up is that you can start to see some general circulation patterns. It's not perfect. It would work better if we had land masses all evenly distributed, or even better if it was just a water planet and you didn't have any land masses at all. Then you could really see it. But in general, you can still see some large scale circulations that get set up, because here's the thing. The winds get it all started, and the winds at the equator generally move this way, which gets water moving from east to west. And between 30 and 60, the winds are getting the water moving generally from west to east. And then if there's water really, really close to the poles, which again, you've got some differences with land masses, generally east to west again. Okay? So if you're talking about starting right here along the equator, and we're looking at our big areas of ocean, you notice that down here, south of the equator, generally water is going to flow westward, and then south, and then east, and then north. And this sets up this big circulation of ocean water. Okay? The Atlantic Ocean is not as large, but you see a similar situation in the Atlantic Ocean. Water moves from east to west near the equator, ducks down south, comes around and moves north. And again, you've got this circulation set up because of the way that the ocean currents are moving. Okay? You have another similar situation in the Indian Ocean. Okay? Now, to the north of the equator, you have something similar going on. It's just the turning is going to be in the opposite direction. So the warm water currents are blowing, or the wind is setting up a warm water current flowing from east to west. So the water's moving this way and then moving away from the equator, okay, and circulating this way this time, which is in a clockwise direction. Over here in the Atlantic, it's a smaller gyre, it's a smaller circulation, but it's the same thing. You have another clockwise circulation, and that's all set up. The winds start it because the winds are the primary thing that make surface ocean currents move, okay? And you have these big loops of circulation that get set up, okay? So we're going to draw those in with purple. Okay, so I've taken a purple marker and I've just basically drawn the loops, okay, that represent those large general ocean circulations. And there's 5 major gyres that we see in the world's oceans. So this one would be the North Pacific Gyre because it's in the Pacific north of the equator. This would be the South Pacific Gyre because it's in the Pacific Ocean south of the equator. This would be the South Atlantic Gyre, and this would be the North Atlantic Gyre, and then this is the Indian Ocean Gyre. Okay? But all of that is driven by the way that the winds blow on the surface of the earth. Okay? Because the winds are what get the ocean currents moving the way they are and get those circulations set up. Okay? Please notice that in general, water near the equator is warm, and so warm water currents carry warm water generally away from the equator. And cold water currents are further away from the equator, But if they're directed back, they're going from high latitudes back toward the equator, like here and here. Okay, so they're bringing cold water toward the equator. Warm water currents bring warm water away from the equator. Okay, but they all work together to create these large circulations. And that's going to help us understand why hurricanes move the way they do and some other things like that. The one last thing I'm going to do is I'm just going to take a little map pencil and color these in. Not dark, just so you can kind of see them a little better. Okay? Okay, so just to wrap it up, you've got your 5 really big ocean circulations known as gyres. I shaded them in just a tad. But this should get you started on how to understand what generally is happening with global wind patterns and how that sets up ocean circulations. And it's going to help us to understand why hurricanes move the way they do and things like that. All right.